Hello, good day to all the students here. So I think in my Google Classroom, I have initially shared three videos. The first one is regarding the digital signals, and the second one is regarding digital systems, and the third one is an overview of digital signal processing. The main reason of sharing these three videos is that before you come to the image processing, you or the digital image processing, you should be having the basic idea of what are digital signals and what are digital systems. Digital signals may be any type of one dimension, two dimension, or different types of signals as we have seen in the lecture, and digital systems will be any type of digital system. So in digital image processing, we have a digital signal, which is a digital image, and it is being generated and processed by a digital system, which is a digital processing system. And we have an overview of digital signal processing, uh, so that you know the basic system. Now going ahead, I'll start off with a very famous quote that a picture is worth 1,000 words. The main reason is that whatever you write in few words, you can represent a lot more with images. So the worth of images are more than sentences. So they have different approximations and different ideas which can be there. If I give you any painting, the painting can be described by various artists in different ways. So images are very important. Now going ahead, in this course we'll be following this particular book, which is Digital Image Processing by Rafael Gonzalez and Woods. There is another book by Anil Jain, but I'll not touch that because that is very much mathematical and dealing with transforms and other things. Whereas this is a very popular book which has less amount of mathematics, as it is an elective course for most of you. So without knowing whether you are having what type of mathematical background, I cannot go directly using the Anil Jain's book. So I'm referring to the Digital Image Processing by Gonzalez and Woods, which is a very popular book. And this is the second edition's image. There is a third edition, fourth edition, as well as the recent fifth edition. Much of the materials of these slides are taken from there, and you can follow it one by one. And the image is available in PDF form also, which you can access very easily. So next, this will be the contents of this particular lecture. I'll be starting off with what is a digital image, followed by what is this digital image processing, and a brief history, and then a few examples of the digital image processing, and finally coming to the key stages of image processing, which is nothing but the contents of the syllabus. Now, what is a digital image? A digital image is nothing but representation of a 2D image as a finite set of digital values in XY coordinates, which are called the picture elements of the pixels. Now, if you have any scene of element and the emulation or energy source falls on it, and we have imaging system through which this illumination energy is reflected by the scene or element, based on which the internal image plane gets a brief signal. Now this signal is approximated as a digitized output, which is here, and which may not be exact as the original scene, but will be approximation of that original scene. Now if you zoom in here for the ear of this deer, you see that the pixel values are typically gray levels that we are having with, and if we have in a color version of this, like this deer's photo, it may be having the red, green, and blue channels playing their part with the gray levels. And we have to remember that digitization is nothing but the digital approximation of this real scene. So if we have one sample per point or one pixel per point, or it is a single dimension, a single pixel element representing the whole thing, which is as a black and white or a grayscale, then we have a 8-bit image as a standard. It may be more than that also, but the standard form is to represent in to the power 8 number of bits, means we vary the data from 0 to 55 pixel intensity, and with that we represent the different gray levels, or from black to white, black being 0 and white being brightest white being to 55. The same thing can be done in three set of channels, where it becomes a multi-channel system. There we have three samples per point, where all the three channels are grayscale, but we have them named as red, green, and blue, and we use these three hues there, and you get a color image. And once we include the alpha or the opacity, this becomes the 4 samples per point, or uh, a 32-bit image. Why this is a 32-bit image? Because 8 bit for each, 8 into 4 is 32, where it is the intermediate one is a 24-bit image. So you might have seen in standard paint, you have the option of saving as 24-bit bitmap. So that is nothing but red, green, and blue. And in case you are having the opacity also, it is 32-bit image. So 8 into 432. So most of the course will be dealing with the grayscale images. Why? Because whatever you do in one sample per point, if you iterate it 3 times or 4 times, you get the other images. So the basic for the basics will be keeping this course restricted to one sample per point, or a black and white, or a grayscale set of images. Now, going ahead, we have made this course focusing on two major tasks. One is improvement of pictorial information for human interpretation, which is a low-level task, and a mid-level image processing, where we have the processing of image data for storage, transmission, and representation of autonomous machine perception based on the attributes. We can have the advances like the image processing for image analysis, computer vision, and so on, but that is a high level thing which we'll avoid. So if I divide this course in this image processing thing into the levels, we have three levels. Low level, where input and output are images; the mid level, where you have images input and output as attributes; and the high level, where the inputs are attributes and the output is the understanding of the images. So in the low level, we have a noise removal of images and image sharpening. So the input is a noisy image, and we get a noiseless image. Or we have a input as an image, we get a sharpened image or smoothened image as output. In the mid level, what we are having is the images are the inputs, and the object recognition or image segmentation or thresholding are taking place, and the outputs are attributes. So this in this course we will restrict ourselves to here, whereas the high-level process, which is dealing with scene understanding, autonomous navigation, and various machine learning and deep learning things using computer vision, are the high-level processes which we will not be touching in this particular course. So going to the brief history, the early 1920s, we had first this images sent by the Bartlett cable, which is underwater sea submarine cable between London and New York. So images were coded for cable transfer in any set of zeros and ones, and it was normally a 2-bit image where you have black and white only, as you can see, and any image is converted into set of zeros and ones, and it is again regenerated in the receiver end. So from there, it was advanced a bit by having a 15-tone digital image later on, by a few improvements in the Bartlett system, where new production processes were there, by increasing the number of tones there and the number of shades there in the reproduced images. As we progressed, we went for in 1960s, where the first picture of the moon was taken by the range Ranger 7, and a lot of image processing was done to improve the received image, which was of less quality due to the noise in between. So mm, from this particular stage, we advanced to where medical images started being processed, and for the computerized axial tomography CAT scans, which have now gone up in MRI and other scans of say 1 Tesla, 2 Tesla, 1.5 Tesla, 3 Tesla, and so on. So a lot of medical image sonography, ultrasonography, MRI, CAT, CT scan, lot of things have come up time to time with the advances of this image processing. This 1980s, from 1980s to till today, we have been using it in various areas for image enhancement, restoration, artistic effects, medical visualization, industrial applications, law enforcement, human-computer interface, brain-computer interface, and many more. So, for a few examples of digital image enhancement, you can see one of the most common uses of digital image processing is to remove noises. Like for this lung image, we have removed the noises and we got the clear picture of the bones. In this PCB images, we have removed the noise salt and pepper noise, and we got a smooth version to understand where the components are connected, or this particular aerial view where foggy or uh, say early morning in the low haze and other type when images are taken, we can clarify and we can get the proper image. So these are just removal of noise of various types, and we can go ahead and enhance the image using various image enhancement techniques. For Hubble telescope kind images, you can see here, this is the image taken, and once it is clarified, you can get much better resolution images by this denoising and various other image enhancement processes. Then artistic effects like VFX is very common these days. The entire VFX group along with video and image enhancement groups are working on the present day science fictions, then Marvel, Avengers and other movies. Then in various medical fields we are using these images. In GIS, remote sensing, with forestry, biodiversity and various other departments use for say classification of the terrains, then meteorology, rainfall data and other things. So settled images are processed. Then you have in industrial inspection, like in case there is some unfilled bottle, if there is any problem in the uh, soldering, if there is any problem in the defect in the things, defect in the rice or grains or the problems anywhere. So when the machine-based processing are being done in the recent years, and as we go ahead for the Industry 4.0, these things are very common, and we have several physical systems being relying a lot on the images. So whether it is PCB inspection, number plate for law enforcement, for number plate verification, fingerprint recognition, biometrics, and many other than human computer interaction like uh, facial recognition, cyber physical systems, lot of image things are done. Now coming to the key stages of image processing, these are the key stages of image processing which will go ahead. So first we have the problem domain, then image acquisition, image enhancement, image restoration, morphological processing, segmentation, object recognition, representation and description. Color image processing and image compression we may touch very less, so that's why I kept them in the dotted line. Going ahead, in the image acquisition part, we will be discussing how an image is formed and other things. This I have given a brief idea already. Next, we'll go for image enhancement, where we'll be doing removal of noise and other things, which is the next chapter of the book. Then we go for image restoration. This is a noisy image is restored, and we get a better image here. Then morphological processing, like uh, here where we can find out the various ways in which we can apply like fingerprint recognition, where we are applying these things and finding out the fingerprints variation via Newtonian. We are doing the nearest neighbors. Different types of neighborhood methods are there, whether they are connected, not connected, disconnected, whether pixels are in a group or outside the group, or in a particular cluster. So there are various morphological processing that we'll be discussing. Then going to the segmentation, where we can segment the images into for different attribute recognition and other things, and object recognition for various parts. We'll be discussing that in the next chapter. And finally, representation and description, what type of object it is and what not. This will be discussing there. Image compression, we will be studying in brief. Some popular methods are already there, GPC and other things. And color image processing, when we apply the same set of things in three dimensions for red, green, and blue channel in iteration, we have the color image processing. So to summarize, here we have looked into what a digital image is, what is digital image processing, a brief history of digital image processing, then few examples of digital image processing, and the key stages of digital image processing, which are the different chapters of this particular book that I am referring to. So next time we'll start and see how it works out. So thank you, and we can discuss these things in the Google Classroom. for the next lecture. So I'll stop today for here. In case you are having some query, you can post them with this lecture.